Let's work towards a class-oriented version of curly. So in the class-oriented version, we have expressions, but around those expressions we have class declarations, and classes have field and method declarations. Fields here, unlike the fields of our objects, are just going to be the name. We won't put an initialization expression with the field. Instead, every time we create an object, then we use new, and the expressions that we pass into new, the values of those expressions will become the values of the object's field. We will have methods as we had in objects, and there's still the name of the method. Arg is always the name of the argument, and then the body of the method as an expression. The expressions are similar to the ones that we've always had, including arg and this for objects, but this new form is new. And we also have send here. This first S stands for static, so this is to implement supercalls, but in a way before we even have a notion of superclasses, just a way of saying that we dispatch to a particular class. So this expression, just like send, is going to be an expression that produces an object. This symbol over here is going to be the same as the send symbol, that is the method that we're calling, and the expression produces the argument to the method. This extra symbol will be the name of a class. So let's look at a few examples. Here is a class-oriented curly program. It's going to be some number of class declarations followed by an expression. And the expression is, you can think of it like the main expression in Java. It's what we start interpreting to get the program running. And in this main expression, we are going to send the addDis method to an instance of the posin class, which is given 1 and 2 for the x and y fields. Those are matched up by position. And then when we call the addDis method, that means we're going to the addDis method in posin and passing it an argument, which is this other object. This other object is a posin with field values 3 and 4. And then we'll call the mdist method on the argument and the mdist method on self. And that's all analogous to this Java program over here, where we have posin with x and y, we create a posin with 1, 2, and pass it a posin with 3, 4, and so on. A Java program that declares a posin class might also declare a posin 3D class that extends it, adding extra fields and replacing or reusing, in some cases, the methods that were provided by the superclass. In our curly with classes language, we don't yet have superclasses. We'll layer that on later, but we can still simulate this organization by having the posin class declared as before, and also declaring posin 3D that just happens to have the same things as posin, plus a little bit more. So we've given posin 3D an x and a y field and a z field, just like this posin 3D has the x and y from its superclass and adds just a z here. And then we've overridden the mdist and the addDis methods. Notice that in the addDis methods in the Java class, then we just defer to the superclass implementation. In fact, if we just leave addDist out in Java, then this is the default implementation that shows up there. But we're going to write it explicitly here because, again, we don't have superclass declarations. And it's a static call because whenever you do the addDis method of posin, we want to use specifically posin's implementation of addDist. On the other hand, mdist is refined in our Java class, and we have a replacement or a different mdist here, different than posin's mdist. At the same time, it still uses a static send with posin here to reuse the mdist implementation, get a sum of the x and y fields, and then it just adds the z field. So this is how we're going to write class-oriented programs in curly and how we're going to, for now, simulate subclassing when we need it.